Hello and welcome to the overview presentation of the Globex Corporation Network Project. This presentation is being delivered by Virtucon, who have been selected as the project managing group who will carry out the planning, design and implementation of the network rollout for the Globex offices at Albury and Wagga Wagga. The presentation will summarise a review of the project itself, touching on the milestones, objective review and budgeting details. It will cover the technical details of the design itself, including the physical and logical details of the network spread across the 3 sites. We will then provide a detailed demonstration of some of the implemented functions of the design to date, in order to give the client further understanding of the technical solution and a basic proof of concept that the project is on track to meet the specified goals. We will firstly take a look at the milestone achievements to date. Approaching the 4th milestone, we recap on the successful completion of the first 3 milestones, relating to the planning, initialization, requirements and design phases of the standard project management lifecycle. The initial milestone was the creation and acceptance of the project charter, which was the initial document that authorised continued work on the project. This document listed the general scope, deliverables and parties involved in the project. Shortly following this was the creation and implementation of the project management plan, which is the comprehensive document produced by Virtucon to outline how the project deliverables will be completed. Both of these documents were completed on 15 March 2015. The next milestone was the completion of the requirement specification document, along with a technical environmental scan and a feasibility study into the provision of cloud services. The purpose of these was to gather what the system needed to do to meet the deliverables. This was presented in terms of functional, non-functional and technical requirements. This document was completed on 9 April 2015. The third milestone was the completion of the initial solution design and a revised project management plan. The purpose of this phase was to comprehensively document the physical and logical plan to achieve the project deliverables, including configurations. Accompanying this was an implementation plan and a test plan for installing and testing the system. This document was completed on 8 May 2015. This slide shows the key project deliverables and indicators of successful accomplishment. These list the goals to be achieved and the measures that were used to identify that each goal is successfully reached. The goals include setting up of users with appropriate technology to carry out their daily work requirements and the setting up of the servers at both Albury and Wagga Wagga sites. It also includes the cloud-based functions, including data backup facilities, as well as web hosting and other network-based enhancements, including monitoring, time server and storage points. Virtucon believes that based on the work completed to date and the current plans in place, that the key project deliverables will be successfully completed on time. According to the project schedule, the work is ticking over nicely. As things stand, work is being completed on time and in budget. There has been no evidence of scope creep or impacts to the critical path. We are confident this will continue throughout the rest of the project. The physical site design can be summarised in 3 parts, which include the physical, data link and network layers, as used as a part of the OSI model. The network cable infrastructure makes use of both copper Cat6 and single mode optical fibre respectively, which was existing infrastructure in place before project engagement. The layout of the server racks provide an organised arrangement of network equipment and power facilities. Cable management will play a role in providing a tidy environment, where devices and cabling can be easily identified. Each rack will consist of 1 UPS that can be used as backup in the event of mains power failure. The network devices and cable terminations have allocated rack positioning that makes allowances for future deployment of additional rack-mounted devices. The network devices, being routers and switches, will use Cisco hardware where Ethernet will be used as the transport of the network. Virtual LANs, or VLANs, will be used to logically separate traffic between the local subnets on site. The design makes use of Layer 2 protocols such as Spanning Tree Protocol and Layer 2 Ether channels, both of which are effective technologies that respectfully provide redundancy and aggregation of link bandwidth between routers and switches. At the network layer, the IP addressing scheme makes use of IPv4 addressing throughout the design. Inter-VLAN routing will route these subnets as required and filter out specified traffic for security purposes, using access control list statements. The routers will make use of network address translation overload for access to the internet, whereby many internal host IP addresses are mapped at the port level to one single external IP address as assigned by the ISP. The network design will consist of the two physical offices at Wagga Wagga and Albury and one virtual site being the cloud. Each of these sites will have a connection to the internet in the form of an ADSL2+ link. Each site will establish two secure VPNs to its two adjacent sites in order to create a full mesh topology. The VPN of choice has been selected as IPsec, due to it offering the strongest level of security of VPNs on the market. IPsec tunnels will be built and routed over the internet to create secure links over an unsecure public network. The primary advantage here is the cost saving that Globex will benefit from over a long term, compared to leasing private line carrier grade connections. The IPsec tunnels at the Albury and Wagga Wagga sites will terminate on the Cisco routers at each site. The cloud Linux server will run the application StrongSwan, which fully supports IPsec and is compatible with Cisco iOS. This software is a simple and cost-effective method of terminating these IPsec connections in the cloud. The end result of the above technical design is, as mentioned, a full mesh VPN, whereby users at each site can consume services from other sites. Examples include Albury and Wagga Wagga users accessing the cloud for their intranet and Wagga Wagga users accessing the Albury site for email. The server roles are a combination of dedicated roles for each site and shared roles to accommodate services at remote sites. Both Albury and Wagga Wagga sites will run Windows Server 2012 R2 and will carry out local directory and client management functions. Both servers will perform system data backups into the cloud for server backups. Company-wide intranet services will be provided through the AWS cloud, using the Apache Web Server software running SUSE Linux Enterprise. Additionally, the web server will run the front end for the Nagios monitoring software. Terminal services will be available for clients to externally access the Globex network remotely using OpenVPN software-based VPN. The terminal services gateway will be implemented on the Wagga Wagga server. The Albury server will run Microsoft Exchange, providing an email server for both sites. The following demonstrations are provided to show some of the features that will be handed over as part of the final solution. The two proofs shown are a ping between sites and the Nagios monitoring platform running. These demonstrate connectivity, encryption, monitoring, web connectivity, and SSH connectivity. Firstly, basic connectivity of site-to-site traffic can be seen from this end-to-end ping between sites. While these pings are running, we will log into one of the Cisco routers using SSH to check the IPsec statistics of the traffic being passed. The show command that is being refreshed shows both connections with incrementing counters of encrypted and decrypted packets. When we stop one of the ping, we see that the counters cease on that connection. This video highlights how Nagios and related check MK monitoring will be implemented through the network. Firstly, we can see the Nagios web interface where the network devices and host statuses can be seen at a glance. This also includes the time of the last status check, comments about the computer or device. The Check MK interface has further information about the servers and routers. These include at a glance network status and key information such as flapping connections. This different at a glance view shows the computer states as well as network addresses and any system problems. It is also possible to view further information about the device, including interfaces and services. This shows the Wagga Wagga router extended information. As we can see, interface 6 Fast Ethernet 011 is currently down. This can be remedied by remote SSH access to the Wagga Wagga router over the IPsec VPN. There is a time gap as the monitor service automatically rechecks the network state. But we can see that interface 6 status has returned to up. Are there any questions?